Problem 3. Design the formwork for an elevated concrete slab 6-inch thick. The seat thin will be the nominal 1-inch lumber, so that lumber, not plywood, keep that in mind. And 2x8-inch lumber for joist, and stringer is 4x8-inch. Assume all the members are continuous over 3 or more spans, so that we can continuous support. Commercial 4,000 pound shores will be used. Just relate to that, the 4,000 pound is allowable working load. Go back to the just previous lesson when we learned the temporary and formwork system. It's estimated that the weight of the formwork will be 5 pounds per square foot. The adjusted allowable stress for the lumber being used as follows. Allowable stress in bendings, the FB 1075 psi, and then for other members for sitting, and for other members mean the stringer and joists 1250. Allowable stress for the shear FV given for the allowable stress for compression perpendicular to grain FC perpendicular, for the joints and stringer 405 psi, and the allowable stress in compression parallel to grain it 850 psi for joints and stringer. So that we look down here. Other member is mean we need to talking about the joints and stringer. And we also give the Young modulus for modulus of elasticity for the sit-in and other member. And as you can see, the sit-in and all joints and stringer are lumber, not plywood. The maximum deflection for the form will be L over 360. And due the minimum value of live load permitted by the ACI, American Concrete Institute, determine the joint spacing. So that what is the joint spacing, stringer spacing, and the shore spacing. So those are the 3 things that we need to determine. And the cross section of that formwork system, it's shown in here. You see the sit-in, and then we have the joints, and then the stringer, and then it will be supported by the shores. And on the plan view that you will see the sit-in, and then the joist, stringer, and also the shore supported the stringer as shown in there. So how can we do it with this? First one, we need to determine the design load, and before we determine the design load, we need to determine the dead load. So go back to the note that we have here. Design load equal to the dead load plus live load, and for live load it have to be 50 psi if it no motorized cart are used. If it on that temporary system use motorized carts, then 75 psi. And the design load similarly 100 at least pound per square foot if it no motorized cars, or 125 pound per square feet if motorized cars are used. So keep that. Now we let to determine the dead load. Let's move down to here. So we have dead load. It equal to concrete, and of course the form, the dead load of the form. So for concrete, if they give us now the unit weight of the concrete, if not, we can assume that 150 pounds per cubic feet, and the thickness of this is 6 inches thick, so we can find out that equal to 6 inches divided by 12 per foot, and the unit weight of concrete 150 pound per cubic feet. And then for the form, the problem given is 5 pounds per square foot in there, so we can plus 5, so we get 80 pounds per square foot. And then when we determine the dead load, we can find out the design. And no motorized cars are used, so it will be equal to the dead load plus live load. And from that one, we have 80 plus no motorized cars. Go to our node, it will be 50 pounds per square foot plus 50. So you have 130 pounds per square foot. So that's the design load. We need to determine the actual dimensions of the sheathing and the lumber for the joist and the lumber for stringer. So you have 1 inch actual dimension, of the member that we talk in here. The first one, the sheathing, and it is 1 inch thick, and that is nominal 1 inch lumber, as you can see there. Then if you go to the reference and go to page number 7, the section properties for US standard lumber and timber, if the nominal size, as you can see in this case, 1/3, then the actual size equal to 0.75 by 2.5. So it's for 1 inch nominal, it will be 3/4 of the actual size, so 0.75. So go down here, we can have the 0.75 inch actual. Similarly, for the joist and for the stringer, what is the joist we have? It's 2/8 and then stringer 4/8 inch. So that is 2/8 inch and this is 4/8 inch. So go to that reference again, and that the reference page 7 of the reference. 2/8, it will be 1.5 by 725, and then 4/8 we have 3.5 by 725. So that is the 1.5, that is 1.5 time, go back down here, 7.25, and then 4/8, 3.5, 7.25. So this is 7.25 inch, and that is 3.5 by 7.25 inch. That actual dimension, and all here you can use to the from the reference, final reference page 7.